will be given by Natalia Levshina of the Max Planck Institute for Psycholinguistics, and it's titled Word Length and Communicative Efficiency, New Insights from Typologically Diverse Corpora. And I'll just remind the presenters again that the talks are 18-minute long. I'm sending you via chat 5-minute and 1-minute reminders. Go ahead.
Yeah, hello. Hope you can hear me properly. I had some sound problems yesterday, but I hope everything will work. Right. Yeah, I want to speak about word lengths and predictability, frequency, and other things. So you all probably know about Zipf's law of abbreviation, according to which more frequent words tend to be shorter than less frequent ones. This has been interpreted as a manifestation of communicative efficiency because this leads to reduction of effort. And this is also universal because it has been observed in all languages where we can have some corpora and measure it. And even interestingly, artificial languages like Klingon support this law. But there was also a very interesting paper, 2011, by Pintado, and Gibson, who argued that actually predictability is more important, and more exactly, they computed average information content, then computed its correlation with word lengths. So what is this average information content? This is, technically speaking, negative average log transform probability of a word in a corpus given the context. Or informally speaking, this is unpredictability given some context. And they measured context based on n-grams, and more exactly, they took 1, 2, or 3 words on the left. And they found, this is one of the plots so using a sample of languages, these are Indo-European languages, that the correlation between average information content is unpredictability given 1, 2, 3 words on the left, and length was actually more, was stronger than the correlation between frequency, like this Zipf correlation. And so they reported this for all these languages. And in a paper on communicative efficiency, this big review paper with many authors, Gibson et al. Argued that this is actually what one could expect based on information theory. So, and they wrote, they worked before information theory provided a mathematical framework for understanding optimal codes. In an optimal code, the length of a signal will depend on its probability in context, not its overall frequency. Right, but I was wondering, what if we include non-Indo-European languages? Will we find the same effects? What also if we take different registers and text types? And also, what is the role of the context on the right? So this may not sound very intuitive, but actually there is a lot of work in phonology that shows that phonological reduction also depends on predictability of the target word given the right context, the word that comes on the next. And sometimes it's even more important than predictability given the word, the preceding word or words. Another thing which is important to mention is methodology. Here there are some methodological issues, and so they were pointed out by Mellon and Griffiths in a paper that actually appeared only a couple of weeks ago in Cognitive Science. And they show that if you measure these correlations, the results depend on a number of methodological choices, in particular character encoding, how you treat diacritics and other things that are popular in English, languages other than English, and also how to treat different kind of noise, because if you use large web-based corpora, there are many misspellings, errors, and also many English words. And actually, if you control for that, you filter out this noise and treat characters in a proper way, then the evidence for predictability is much more nuanced. And actually, only in English and French, only 2 languages from the same sample as Pintado et al. Predictability is most strongly correlated with length and frequency. And in Czech, Dutch, Polish, Spanish, and Swedish, frequency is actually more important. These are their results. Right. Now, for my case study, I took several typologically diverse languages. So I took Arabic, Finnish, Hungarian, Indonesian, Russian, and Turkish. Also took English, but I'll speak about that later. So I took the data from Leipzig corpora collection, which is they have different corpora of different sizes from more than 200 languages, and it's online news and miscellaneous web communication. So I got 10 million sentence corpora. So this is just randomly shuffled sentences. These are not texts for copyright reasons, apparently. So, and I want to thank Felix Helfer from Uni Leipzig for his help. Then, so I took used UTF-8 coding and normalized everything to lowercase, and I did a lot of cleaning. So first of all, I removed numbers and punctuation. I also removed all words, all tokens that don't occur in open subtitles, this opus corpus by Jörg Tiedemann that many people use as kind of standard. And I also use spelling dictionaries, Handspell and Microsoft Office for Finnish in order to filter out potential words from other languages and so on. Right, so these are the numbers which I had before cleaning and after cleaning. You see the differences are great, but of course, this before cleaning includes punctuation numbers and all kind of symbols and many things. Then, as for data extraction, I took 10,000 most frequent unigrams, so words, as units of analysis. So these are the words that I will, for which I'll compare correlations between different predictability measures, frequency and length. And so to give you an idea, the frequency of the least frequent word in each language was greater than 500. So this means that there's at least some data to relate their predictability. Of course, if a word occurs only once, then you can't get a reliable measure of predictability in given context. Then, and then I also only took bigrams. That means that I only computed predictability given the next word and the previous word. And so I kind of filter out bigrams too for cleaning purposes and also because of computational constraints. But I think this is also what you get if you use Google data and so on. So I only took bigrams that include unigrams components with frequency greater than 9 and that also occurred in these dictionaries and in open subtitles. So these the results that I'm going to show you now are based on unsmoothed n-grams, bigrams, probabilities, but I'm also working on smoothing, but it's very low, very slow. My script is still running. And also I took several registers from corpus of contemporary American English. I took academic text, news, magazines, fiction, and spoken part. That it's not really what you would think. It's not spontaneous conversations, but it's TV and radio transcripts, but also better than nothing. And so I performed the same cleaning procedure, but without subtitles control, because of course films have their own genre. I don't want this bias. So these are the data in before and after cleaning, the number of tokens. Right, and from these data, I took a negative frequency. So it just was transformed so that, I could easily visualize everything and compare the correlations with predictability. Then I took average information content given the previous word, given the next word, and word length measured in UTF-8 characters. So, and these are just results, my correlations. So this shows these measures a negative frequency, information content given previous word, so unpredictability given previous word, unpredictability given next word, these blue bars. And so it shows the y-axis shows the correlation with word length. And these are Spearman's rank-based correlations, so as used in the previous studies. Right, I also show here partial correlations, but they are a bit trickier to interpret. So then these are the results. And in Indonesian, we see that in the predictability given previous word has the strongest correlation with word length, as we would expect based on Pintadossi et al.'s paper. So it's followed by frequency and then predictability given next word, right? So this is what we expect. But actually, this is the only language in the sample where I got something that I expected based on Pintadossi's work. So if we take Arabic, for example, it's totally different. Even there is a negative correlation between predictability given previous word, like this green bar in the middle, and the strongest correlation is between length and information content given next word, this blue bar, and it's followed by frequency. So I'll get back to this later, why I think there is negative correlation. So this is what we find in Finnish now. So here frequency is the most important, and it's followed by predictability given next word, and finally information content given previous word. It's pretty low. And the same for Hungarian. Right, for Russian, there is basically no difference between effects of the negative frequency and predictability given previous word. And again, we have a negative correlation, predictability given the next word. Okay, and finally, Turkish. In Turkish, the most important thing is information content given next word, and then it's followed by frequency, and no effect at all of information content predictability given the previous word, right? Okay, so to summarize, what we see is that predictability, or in other words, in this more exactly, precisely, information content given previous or next word, it's more prominent than frequency in Indonesian, Arabic, and Turkish. In Finnish and Hungarian, frequency beats the two predictability measures. And in most languages, except Indonesian and Russian, in most of these languages, predictability given next word is more important actually than predictability given the previous word. And there are also some negative correlations in Arabic and Russian. Right, how can we explain this finding? I think some the typological properties may play a role here. So first of all, word order. I guess that's maybe about the branching direction. For example, Turkish, Finnish, and Hungarian have postpositions in different degree, and OV also in different degree. And also another thing is maybe a flexibility of word order and how much language users can rely on neighboring words and infer these predictability effects. If the word order is more variable, then you can't really rely on this information, right? So predictability should play a less important role. Then another factor is probably obligatory morphology, because if you have many morphemes that make word longer or shorter, and they capture grammatical relations and meanings beyond these very local engrams, like tense-aspect mood, markers, argument structure, probably this would also play a role here and weaken the effect of predictability, because there are some obligatory rules that have to be observed and based on the properties of the utterance in general. Like, for example, Russian has case marking with different case markers have different lengths and also zero. And this depends on the head word or head verb, which governs these forms, and also the syntactic function. Or Hungarian, for example, has possessive head marking, which is these markers written together with a noun, and so this is probably not very can be inferred from predictability, from engram predictability at least. So this just graph supports this interpretation, showing this on the x-axis, the kind of morphological richness as type token ratio. There is a very simple operationalization, so that Indonesian has the lowest rank and Finnish has the richest morphology. And the y-axis shows the mean word order entropy based on universal dependencies. So it's kind of word order freedom, which is higher in Russian, Finnish, Hungarian, and lower in Indonesian, Arabic, and Turkish. So English would be, I guess, somewhere like Indonesian, maybe even a little bit lower. Right. So, and so negative correlations, it's very difficult to find an explanation, but maybe in Arabic, this negative correlation between length and information content given previous word can be due to the definite, at least I was looking at the examples in the corpus and the values. So maybe it has to do with the definite genitive construct, but I guess there's something similar in Hebrew. And so this highly predictable, this genitive part is actually long because it also carries the article. So I don't know. And in Russian, I see very many combinations of adjective and noun, where adjective is actually highly predictable because all these are kind of set formal expressions like software or stainless steel or distinctive feature. But it's very morphological complex because there is a agreement marker, the taste, tense, gender, and number, and also there are different suffixes that derivational suffixes there that form adjectives. So that's, I guess, for Russian is not very efficient in that regard. Then, and now turning to register in English, so American English. So these are the same correlations for the different sections of the corpus of contemporary American English with and we can see that only in academic text and in the news, there's some preference for the stronger correlations between length and information content given previous word, these green bars in the middle. And so the other registers don't show that, and even in fiction, there's actually I think pretty clear fact that frequency is more important. And one may ask why we find this. So maybe in some registers, the reader relies on the text itself, like in news and academic text, and maybe there's more extra linguistic context, or maybe a larger context, like in fiction, there's the space of the entire novel. And maybe also the pressure for compactness is stronger in more informative text and lower in entertainment text and in spoken discourse due to, also because there are other pressures, like pressures of online processing. So these are my tentative explanations. And so to summarize, I think still this Gibson et al.'s idea about predictability as being extremely important, maybe more important than frequency itself, I think it's still intuitively appealing to me. But so predictability is big, and n-gram-based predictability is only a small part of it, I guess. And maybe n-grams are not the optimal way of measuring predictability for languages with more flexibility in word order or rich morphology, or when the register text type relies more on non-verbal context and there is no pressure for compression, and there may be some other pressures in the air. So, and I would like to finish with this question. What kind of, then I think we all should understand very clearly and think about it more, what kind of contextual information is relevant for formal reduction, and how can we actually measure it? So that's my core question for the moment. So thank you very much.
Thank you so much. That was really interesting, and you guys can, especially see Yotam is raising his hand.
Thank you very much. I was wondering about several things, like why remove the numbers, for example? A number is a part of the text. It might predict certain words after it, or also when dealing with Arabic, it has a very, very different orthography. A three-letter word might be qabla before, which has you know, only two syllables and certain number of segments, or qabbala, kissed, or something like that, with three syllables and much more, another vowel and another consonant. So I mean, that doesn't even, the number of letters doesn't even necessarily reflect properly the actual length of the word, especially when we were talking about the definite article, which is always two letters, but often only a single consonant. So, I mean, I think you're getting skewed here in so many ways by the methodology. It's a real problem.
Yeah, okay. I took Arabic for, typological diversity. I'm fully aware that, it doesn't represent what they say, but even when we take English, English corpora, they don't represent what people say in the actual word length. But actually there were some robust correlations if you take just transcriptions, some, I don't know, some lexical resources that provide actually a number of phonemes, and then there is still a correlation. I would still, I guess, expect some correlation. It's interesting also that frequency is pretty robust here. It still predicts length. That's kind of interesting. So as for numbers, yes, you're right. Maybe in the next case study, I should include that as a feature, as predictive feature, and but still, I wouldn't include that as a target for it, definitely, because it's. I think here the contrast between how much you see and how much is pronounced is probably the greatest. Although I still it might be interesting to include those two, but yeah.
Thank you, Eitan.
Natalia, thank you for this really beautiful and thought-provoking talk. So I think in a traditional kind of functionalist and usage-based thinking, there's a particular relationship between predictability and frequency and assumptions about cognition. And since you've really teased these things apart and looked at them separately, I wonder if you have some kind of, I don't know, qualitative story that you could help us understand how you see the relationship between these things.
Oh yeah, it would be really great. So I guess that so Zipf, at least himself, provided a story that kind of explains why this correlation emerges, and in particular there are some mechanisms like clipping, which is probably many people know, but maybe not the most important mechanism, but lexical replacement using a shorter lexeme, and I think it's been observed in many interesting diachronic case studies, how the more frequent and maybe extralinguistically more relevant, more predictable concept got finally a shorter and more efficient label. With predictability, I guess something very similar should happen. Yeah, right. So this is also what we see. I guess grammaticalization also plays a role that's ignored usually. Didn't mention that, but definitely that's a very important factor. Although I must say that in my sample, as you increase the sample size, then with more and more you get nouns and adjectives on this kind of and functional word, they appear only. They make a small fraction, so that probably doesn't explain all variation in the data. So maybe a small fraction only. Although the other thing is, of course, is that if you take Bybee's approach and this forming of chunks, then it kind of would go against, this efficient reduction. Although in the long run, I don't know how reliable words are as a unit of analysis. So it's chunking still will lead to general reduction of the message. I guess ideally we should compare the overall take this kind of cost function and compare the length of the whole, I don't know, corpus or something like this.
Thank you. We have time for one more quick question, Mira.
Okay, so I'm really ignorant in these matters, but did you try combining factors? Namely, if you take a language that likes frequency, but throw in predictability with previous and future word, does that improve your findings or not? Was that tried? And if yes, what's the result? Because these factors don't contradict each other. Maybe.
Oh, no, they actually, the problem is that they are strongly correlated. And for the analysis, putting all them together, sometimes it leads to strange results. Oh, okay. So that's difficult to interpret because of these correlations, and so of course I think ideally it would be possible. So maybe when I kind of learn how to deal better with this correlation. Yeah,
All right,
one could
thanks.
also take into account, I don't know, so have a big regression with everything, and then also part of speech or something like this. So then one needs a lot of computational power for that, of course. And